Welcome back. So far in this series on sorting algorithms, we have talked about three of the sorting algorithms. Those are bubble sort, selection sort, insertion sort. And we have seen that these algorithms are not so fast as they are all having order of n square as average case complexity. Now in this lesson, we are going to talk about one algorithm which is having order of n log n as worst case complexity, and this algorithm is merge sort. Order of n log n in worst case is definitely a lot better, a lot faster than order of n square in average case. So in this video, we will study, discuss and analyze merge sort algorithm. So before going to this, there is one prerequisite for this lesson. You should have at least heard about recursion as a programming concept. Okay, so let's get started. Merge sort is a complex and fast sorting algorithm that repeatedly divides an unsorted section into two equal subsections and sorts them separately, merges them correctly. So we'll see what is the definition of merge sort. Merge sort is a divide and conquer algorithm, and it divides input array into two halves, calls itself for the two halves, and then merges the two sorted halves using merge function. So there are mainly three steps involved. So those are divide, conquer and combine. Divide the problem into two sub-problems that are similar to the original but in smaller size. Conquer the subproblem by solving them recursively. If they are small enough, just solve them in a straightforward manner. Combine the solutions to create a solution to the original problem. Now we'll see an example. Consider an array which is having 6 elements from 0th index position to 5th index position. We should rearrange the elements in ascending order using merge sort algorithm. So always remember, while we are using the merge sort, we need to take the two variables. One is beginning and one is ending. Beginning is nothing but the starting index of element, and ending is nothing but last index of the array. So here the 5 is the starting index of the array, so we need to denote that with the big, and 6 is the last index of the array, so that will become the end. So now we need to check the condition whether big less than end or not. If big less than end, we need to find out the mid, so by dividing the array into two halves. Okay, is big less than end here? Yes, so divide the array into two halves. To do this process, we need to find out the mid. As we all know that to find out the mid, we are having big plus n by 2 as a formula. So now 0 plus 5 by 2 is equal to 2. Here we are only taking the integer part. So now we have divided the entire array into two halves by finding the mid. Okay, so first consider the left sub array. Okay, first consider the left sub array. So this is the left sub array. Again, take the two variables beginning and ending. 5 is the big element and 3 is the end element. Check the condition. Is big less than end? Yes. So find the mid. 0 plus 2 by 2, that is equal to 1. Divide the left sub array into two halves. Okay. Now consider the left sub array. This is the left sub array. So what we need to do now? Again, denote this left sub array with big and end. So what we need to do now? We need to check the condition. Is big less than end? Yes. Find out the mid. 0 plus 1 by 2 is equal to 0. Again, we will again consider the left sub array. That is 5 and 4. Okay. We need to consider only left sub array. That is 5. As left sub array is having only one element, so we will now consider the right sub array. This is the right sub array. As there is only one element in both the left sub array and right sub array, we will now sort them and merge them back. Is so as 4 is less than 5, so we need to swap the positions of 4 and 5. Okay, so after swapping, this becomes like this, 4 and 5. So the left sub array is sorted now. This is the left sub array. So this is sorted now. Now consider the right sub array. As right sub array is having only one element, that element should be sorted with the left sub array. Okay, are you following? So the right sub array is having only one element, so we should sort this right sub element with left sorted sublist. After that, so this is the array we are having. Okay, so now the left sub array is sorted. So this is the left sub array. Initially we are having as 5 4 3. After doing this process, we will get the left sub array as sorted. Now we will consider the right sub array. Now we will consider the right sub array. So this is the right sub array. The same process will be doing here also in the right sub array. So to start the process, we need to take the two variables beginning and ending. So where 1 is the beginning and 6 is the ending. Is beginning less than end? Yes. So find out the middle. That middle equal to 1. So divide the array into two halves, left array and right array. So consider the left array first. So this is the left array. Again, take the beginning and ending. Check the condition. Beginning less than end. Yes. So mid is equal to 0 plus 1 by 2, that equal to 0. Divide into two halves. And consider the left subarray. As the left subarray is having only one element, consider the right subarray. This. The right subarray is also having only one element. So as both the right subarray and the left subarray are having only one element, we need to sort them. Okay, so 1 is less than 2 only, so there is no need to sorting the elements. So we can move to the right subarray. As right subarray is having only one element, that element should be sorted with the left sorted array. Okay, so after that 1 and 2 both are less than 6, so we don't have to swap the positions. Okay, now as both the left sorted left sub array and right sub array are sorted, we just have to merge them in ascending order using merging algorithm. So the elements are not in the ascending order in the given array, so we need to rearrange the elements in ascending order using the merging algorithm. So this is the actual array. So this is the left sorted array and this is the right sorted array. Now the 1 will replace the 5, 2 will replace the 4, 3 will replace the 3, 4 will replace the 1, 5 will replace the 2 and 6 will 6 only. So this is how we need to rearrange the elements in ascending order. So at last we will get the array like this. Yes, the array is sorted now. So this is how we need to do the merge sort in an example. We will see the algorithm now. Take the algorithm name merge sort, which is having the three parameters: array name, beginning variable and ending variable. So we need to check the condition whether big less than end or not. If it is yes, then we need to find out the middle to divide the array into two halves. For that we are having the formula middle equal to big plus n by 2. Here middle is taking the variable as m. So next we need to do the first half. So to merge the first half, we need to call merge sort of array name comma big comma m. Okay, to measure the second half we need to call merge sort of array comma m plus 1 comma n, and measure the two halves sorted in step 2 and step 3. So we need to measure them using the call merge of array comma big comma m comma n. This is the algorithm. It is having the complexity as order of n log n. And why we use merge sort? It is faster while we are comparing with insertion sort. On small inputs, insertion sort may be faster, but for large enough inputs, merge sort will always be faster because its running time grows more slowly than insertion sort. What are the features of merge sort? It performs in order of n log n in the worst case, as it is stable and quite independent of the way the initial list is organized. So it can be good while we are using the linked list, and it can be implemented in such a way that the data is accessed sequentially. And the main drawbacks of this merge sort is it may require an array of up to the size of the original list, and this can be avoided, but the algorithm becomes significantly more complicated, making it worthwhile. Instead of making it complicated, we can also use heap sort, which is also having the complexity as order of n log n, but you have to remember that heap sort is not stable in comparison to merge sort. So now we'll see what are the applications. The merge sort allows large data sets to be sorted easily, and merge sort accesses data sequentially, and the need of random access is low. And we can also use this merge sort in inversion count problem, and we can use it in external sorting, and we can use in organizing an mp3 library while we are displaying Google PageRank results. And of course we can also use in e-commerce applications. Okay, so these are the applications of merge sort. So in overall we have discussed what is merge sort and why it is important with example, and what is the algorithm and how to calculate complexity, and what are the main steps involved in merge sort, what are the features, drawbacks and applications of merge sort. So hope you all understand this video. Thank you.